In this lecture we'll answer two questions. In the first question, we'll find out the length of the height AB of this right angle ABC. And in the second question, we'll find out the area of this square ABCD and also the length of line segment PQ or tangent PQ. So we start with the first question. In the drawing, we have the right angle ABC. This is angle ABC, this is right angle. We know that the radius of this circle equals to 4 units in its length. Actually, the circle is inscribed by this right angle ABC. We also know that BC equals to 4 units in its length. Again, our test is to find out the length of AB, which is also the height AB. If the base of this angle ABC is BC, then the height is AB. So we have to find out the length of AB. So first of all, we'll define the relevant points to this question with letters. We define the center of this circle. This point is point O. Likewise, we define the point of tendency of tangent AB of this circle. This point is point E. We define the point of tendency of tangent BC with this circle. This point is point M. And finally, we define the point of tendency of tangent AC with this circle. This point is point F. So in the next step, we will join points O and M together by straight line. Point O is the center of this circle, point M is the point of the circle itself. Therefore, OM is the radius of this circle, that is equals to 4. Here we can implement rule 1. Well, we have the radius OM, this is equals to 4. The radius OM is 1 to point M, that is the point of tendency of tangent BC with this circle. Whenever you have a radius that is 1 to the point of tendency, then tangent BC will be perpendicular to the radius MO. If BC is perpendicular to MO, it means that this angle equals to 90 degrees in its side. This angle also equals to 90 degrees in its side according to rule 1. Likewise, we join points O and E together by straight line. OE is of course the radius of this circle. This is equals to 4, according to what is the answer question. The radius OE is equals to 4. The radius OE is drawn to point E, that is the point of tendency of the tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius EO. If AB is perpendicular to EO, it means that this angle equals to 90 degrees in its sides. And this angle also equals to 90 degrees in its sides according to the same rule, rule 1. So in the small quadrilateral OEMB, in this small quadrilateral OEMB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4 angle, in total must be equal to 360 degrees. According to the rule, it says that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this 4 angle must be also equal to 90 degrees in its size. So in quadrilateral OMBE, we have 4 angles. Therefore, we can relate to quadrilateral OEBM as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in the small rectangle OEBM, side OE must be equal to the opposite side BM. But OE is 4, therefore the opposite side BM must be also equal to 4 units in its length. Likewise, according to the same rule, in the small rectangle OEBM, the side OM must be equal to the opposite side EB. But OM is 4, therefore the opposite side EB must be also equal to 4 units in its length. So répondons de quadrilateral OEBM is not a rectangle but a square. Well, because of the fact that all of its sides are equal to each other. Each side equals to 4 units in its length. Here we can implement rule 2. If we speak rule 2, according to rule 2, the lengths of two tangents from a common side point to a circle are equal. So in the drawing we have a circle. This is the common side point, point P. From this common side point, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule, two are equal to each other. That is to say, PA equals to PB. So we can actually implement rule 2 in our drawing. Right, well, in our drawing, we focus on this common side point, point C. For this common side point, point C, we have two tangents to this circle, tangent CM and tangent CF. And according to rule 2, they are equal to each other. That is to say, CM equals to CF. CM, MC equals to BC minus BM. And again, CM equals to BC minus BM. So CM equals to BC, BC is 40 according to what is given in the question, minus BM, BM equals to 4. So in total, CM equals to 40 minus 4, that is 36. CM equals to 36 units in its length. And again, CM equals to 36 units in its length. And according to rule 2, we already found out that CM equals to CF, but CM is 36, therefore CF must be also equals to 36 units in its length. In the next step, we focus on this common side point, point A. From this common side point, point A, we have two tangents to this circle, tangent AE and tangent AF. According to rule 2, they are equal to each other. That is to say, AE equals to AF. So if we define the length of tangent AE as x, then the length of this tangent AF must be also equal to x units in its length. In the next step, we implement the Pythagorean theorem on this big right triangle ABC. Repeat again, we implement the Pythagorean theorem on this big right triangle ABC. According to the Pythagorean theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this right triangle ABC, in this right big triangle ABC, according to the Pythagorean theorem, here by PT is the relation for Pythagorean theorem. So according to the Pythagorean theorem, in this right triangle ABC, AC squared, that is the square of the hypotenuse, must be equal to AB squared plus BC squared. Which again, according to the Pythagorean theorem, in this big right triangle ABC, the following equation is true. AC squared, that is the square of the hypotenuse, must be equal to AB squared plus BC squared. AC equals to x plus 36, therefore AC squared equals to x plus 36 squared. And it is equal to AB squared. AB is x plus 4, AB is x plus 4, therefore AB squared is x plus 4 squared. Plus BC squared. BC equals to 40 according to what is given in the equation. Therefore, BC squared is 40 squared, that is 1600. So in total, I should find out that x plus 46 squared equals to x plus 4 squared plus 1600. Here we open the brackets on both sides of this equation, and we get that x plus 46 squared equals to x squared plus 36 squared. 36 squared is equal to 1296 plus 2 times x times 36. 2 times x times 36 is plus 72x in total. In the other side of the equation we have x plus 4 squared. X plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is 8x, plus 1600. So then we found out that x squared plus 1296 plus 72x equals to x squared plus 16 plus 8 squared plus 1600. Here we have x squared on both sides of this equation, so x squared gets cancelled. After cancelled x squared, in this side of the equation we have 1296 plus 72x equals, well, on the other side of the equation we have 16 plus 600 is 1616 plus 8x. So here we subtract 8x from this equation. So here in this side of the equation 8x will get cancelled. While on the other side of the equation we have 72x minus 8x is 64x plus 1296 equals to 1616. So here we subtract 1296 from this equation. So in this side of the equation 1296 will get cancelled. And we left only with 64x. Well, on the other side of the equation we have 1600 minus 1296 is equal to 320. So in total we found out that 320 equals to 64x. Here we divide this equation by 64 and finally get that x equals to 320 over 64 is 5. So x equals to 5 units in its name. A equals to x and x equals to 5. We are looking for the length of AB. AB in total equals to x plus 4. AB equals to x plus 4. That is to say AB equals to x, that is 5, plus 4. 5 plus 4 is 9. So in total we found out that the height AB equals to 9 units in its name. And again, in total we found out that the height of this line ABC, the height AB equals to 9 units in its name. So we finished with the first question. In the next step, I present you the second question of this lecture and an answer to the second question of this lecture. In the second question, we have to answer on two questions. The first question is to find out the area of this square ABCD And the second question is to find out the length of this tangent PQ. So in the drawing we have a quarter circle and a circle inside this square ABCD. The quarter circle and the circle touches each other at this point, and we have also tangent PQ that is tangent to both the quarter circle and the circle. So the first question our test is to find out the area of this square ABCD. We also know that the radius of this semicircle equals to 17 units in its length, and the radius of this quarter circle equals to 36 units in its length. So it is known. This is the radius of the quarter circle. This equals to 36 units in its length. We define the center of this semicircle. This point is point O. So AO equals to 17. This is the radius of the semicircle. Likewise, we define this point as point K. So OK is also the radius of this semicircle. This equals to 17 units in itself, according to what is given as the question. We define the length of this short line thread KB as X. We define this point as L. And we define the length of BL, this short line thread BL, as Y. So first of all, we have to find out the area of this square ABCD. What is the area of square ABCD? Actually, we know that the area of any square equals to the length of one side squared. The length of one side squared. That is the area of any square. So we choose the side of this square as AB. So it will be AB square. The length of our square ABCD equals to the length of one side AB squared. But we already found out that AB in total equals to 17 plus 17, this is 34 plus X. So in total AB equals to 34 plus X units in its length. AB equals to 34, therefore AB squared, again AB equals to 34 plus X, therefore AB squared must be equal to 34 plus X squared. That's actually the area of this square ABCD. So in total, according to the first method of calculation, we actually found out that the area of our square ABCD is equal to 34 plus X square units in its size. That is for one side. In the next step, we choose side BD, the side of this square. And according to the second method of calculation, the area of the same square ABCD must be equal to the length of one side squared. So we choose side BD as the length of side BD, so it is BD squared. BD squared. According to the second method of calculation, the area of the same square ABCD equals to BD squared. BD in total equals to 36 plus y, therefore BD squared equals to 36 plus y squared. So according to the second method of calculation, we actually found out that the area of any the area of the same square ABCD equals to 36 plus y 36 plus y squared units in its size. According to the second method of calculation, the area of the same square ABCD is equal to 36 plus y squared units in its size. So we have two different equations for the area of the same square ABCD. Therefore, we will create the equation 3 that says that the area of square ABCD, according to the first method of calculation, must be equal to the area of the same square ABCD according to second method of calculation. Very simple equation. So according to equation 3, we get that the area of square ABCD according to the first method of calculation equals to 34 plus x squared. And it must be equal to the area of the same square ABCD according to the second method of calculation. According to the second method of calculation, the area of square ABCD equals to 36 plus y squared. So in total, according to equation 3, we should find out that 34 plus x squared equals to 36 plus y squared. Here we'll take out of this equation and get that according to equation 3, the square root of 34 plus x squared equals to 34 plus x. Actually, the square cancels, the root cancels the square, and we left only 34 plus x in this side of the equation. Likewise, here, the square root of 36 plus y squared equals to 36 plus y. So in total, we found out that according to equation 3, 34 plus x equals to 36 plus y. Here we'll subtract 34 from this equation 3, and we found out that in this side of the equation 34 we get cancelled, the left only with x. And on the other side of the equation we have 36 minus 34 is 2. So in the other side of the equation left only with y plus 2. So in total we found out that x equals to y plus 2. X equals to y plus 2. In the drawing, we have an external notch between the semicircle and the quarter circle. That is to say, they touch each other externally at this point. This is their touching point. So we define their touching point. This point is as point K. Whenever you have an external notch between two circles or semicircles, you can implement rule 10. So please click on rule 10. According to rule 10, if two circles touch each other externally, then the straight line that connects the circles together passes through their touching point. So in the drawing, we have those two circles. The center of this circle is here at point O, the center of this circle here is here at point M. The straight line that connects the circles together is of course the straight line OM. And according to this rule 10, the straight line OM must pass through their touching point, that is point P. Again, the straight line OM must pass through point P, that is their touching point. Or OPM is one straight line. Again, OPM is one straight line. See, if OPM is one straight line, it means that OM in total must be equal to OP plus PM. So we can implement rule 10 in our drawing. Likewise in our drawing, we have an example notch between those two, the semicircle and the quarter circle at point K. So according to rule 10, the straight line that connects the circles together, the straight line of this semicircle is at point O. The straight line of this quarter circle is at point D. And the straight line that connects the circles together is of course the straight line OD. According to rule 10, the straight line OD must pass through point K. For point K, this is the touching point. Or OKD is one straight line. Again, OKD is one straight line according to rule 10. So join points O and D together by straight line, and according to rule 10, the straight line OD must pass through their touching point, that is point K. You can see that indeed the straight line OD passes through point K, this is the touching point, exactly according to rule 10. OK is the radius of this semicircle, that equals to 17 units in its length. dk is the radius of this quarter circle. This is equal to 36 units in its length. So in total, according to rule 10, OD equals to OK plus KD. Again, OD in total equals to OK plus KD. So OD in total equals to OK, that is 17, plus KD, that is 36. So in total, OD equals to 17 plus 36, that is 53. OD equals to 53 units in its length. So it's down. This is the square, therefore this is the right angle. So in the next step, we'll implement the Badal theorem on this right triangle OBD. But again, we'll implement the Badal theorem on this right triangle OBD. According to the Badal theorem, in any right triangle, the square of the hypotenuse equals to the sum of the slope of the perpendiculars. So in the right triangle OBD, it means that here by PT is the version for Badal theorem. So according to the Badal theorem, in this right triangle OBD, the following equation is to OD squared, that is the square of the hypotenuse, equals to DB squared plus OB squared. And again, according to the Badal theorem, in this right triangle OBD, the following equation is to OD squared, that is the square of the hypotenuse, equals to DB squared plus OB squared. So OD is 53, therefore OD squared is 53 squared. 53 squared is 2,809, and it equals to DB squared dB is y plus 36. Again, dB is y plus 36, therefore dB squared is y plus 36x. Plus OB squared. OB in total is 17 plus x, therefore OB squared is 17 plus x squared. So in total, we found out that 2,809 equals to y plus 36x plus 17 plus x squared. We already found out that x equals to y plus 2. According to equation 1, x equals to y plus 2. Therefore, we can substitute x in this equation by y plus 2. We do it now, we get that 2,809 equals to y plus 36x. And here we have 17 plus x. X is y plus 2, so 17 plus x is 17 plus 2 plus y. 17 plus 2 plus y is 19 plus y squared. So in total, we found out that 2,809 equals to y plus 36x plus y plus 19x squared. Again, 12,809 equals to y plus 36x plus 19 plus y squared. So here we'll open the brackets on this side of this equation and get that 2,809 equals to y plus 36x. Y plus 36x equals to y squared plus 36x squared. 36x squared equals to 1,296 plus 2 times y times 36, that is actually plus 72y plus 19 plus y squared. 19 plus y squared equals to 19 squared. It's actually equal to 361 plus y squared plus 2 times y times 19 is 38y. So in total we found out that 2809 equals to y squared plus 1296 plus 72y plus 36y plus y squared plus 38y. So y squared plus y squared is 2y squared. (72y) plus 38y equals to 110y. Here we have 1296 so we're left only with 1296 here. Actually it is 1296 plus 361 of course, because 19 squared is 361. So 361 plus 1296 is equal to 1657. On the other side of the equation, we have 2809. So in total, we found out that 2809 equals to 2y squared plus 110y plus 1657. So here we subtract 2809 from this equation. So this side of the equation we left in nothing, that is to say 0. While on the other side of the equation we have 1657 minus 2809 equals to minus 1152 plus 2y squared plus 110y equals to 0. Here we divide this equation by 2 and get that 2y squared over 2 is y squared, and we have 110y over 2 is 55y, minus 1152 over 2 is equal to minus 576. And 0 over 2 is 0. So we found out that y squared plus 5y minus 576 equals to 0. And again we found out that y squared plus 55y minus 576 equals to 0. So copy this equation to a new page here. Y squared plus 55y minus 576 equals to 0. This is a quadratic equation, and the general formula for a quadratic equation is as follows: ax squared plus bx plus c equals to 0. In this general formula, for a quadratic equation, a, b, and c are the coefficients of the quadratic equation. And x is the variable that we are looking for. And find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Now specific quadratic equation, that is to say y squared plus 55y minus 576 equals to 0. The variable that we are looking for is y. That is to say x equals to y. So in this for x, we have to substitute x by y, because x equals to y. Y is the variable that we are looking for. The coefficient a equals to 1. The coefficient b equals to 55. And finally the coefficient c equals to minus 576. So if you have all the data that is needed in order to find out the variable that you are looking for, in this quadratic equation, that is y. Y is the length of this short line segment BL. So we just have to put the data of our specific quadratic equation inside this general formula for x. This way we find out the value of the values of y, because y might have two solutions. We do it now, we get that x equals to y, so x by y, and it equals to minus b. b is 55, therefore minus b is minus 55, plus minus square root of b squared. b is 55, therefore b squared is 55 squared. 55 squared is equal to 3025. This is b squared minus 4 times a times c. So minus 4 times a is 1, so minus 4 times 1 is minus 4, times minus 576. Minus 4 times 176 equals to 2304. Divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So total we found out that y equals to minus 55 plus minus. Inside the root we have 3025 plus 2404. So 3025 plus 304 equals to 5329. Divided by 2. So y in total equals to minus 55 plus minus, and the square root of 5329 is equal to 73 divided by 2. So here we have two solutions that are possible for y. One of the solutions is a negative solution, So we take into account only the positive solution because y is the left and the left it must be a positive number. So the positive solution for this equation is as follows. Y equals to minus 55 plus 73 over 2. And again, the positive solution for this equation is y equals to minus 55 plus 73 over 2. Minus 55 plus 73 is 18, and 18 over 2 is 9. The total we found out that y equals to 9 units in its length. Y equals to 9 units in its length. But we already found out that x equals to y plus 2. X equals to y plus 2 according to what we already found out. So x equals to y is 9, 9 plus 2 is 11. So total we found out that x equals to 11 units in its length. Then again, total we found out that y equals to 9 units in its length, and x equals to 11 units in its length. Our task is to find out the area of this square ABCD. We know that the area of square ABCD is equal to the length of one side squared. We choose one side as AB, so it is AB squared. AB squared. AB in total equals to 34 plus x. 34 plus x. Therefore, AB squared must be equal to 34 plus x squared. 34 plus x is 34 plus 11 because x equals to 11. So it is 34 plus 11 squared. 34 plus 11 is 45, so it is 45 squared. 45 squared equals to 2025 square inches in size. So in total we found out that the area of this square ABCD is equal to 2025 square inches in size. So write it down. The area of the square ABCD is equal to 2025 square inches in size. The area of this square ABCD equals to 2025 square inches in size. So the next step, we find out the length of this tangent PQ. That is the second part of the question. What is the length of tangent PQ? This is square ABCD, therefore this is a right angle. This is also a right angle. We have tangent PQ is tangent to this quarter circle at point K. Again, tangent PQ is tangent to this quarter circle at point K. The radius dk is drawn to point K, that is the point of tendency of tangent PQ with this quarter circle. Whenever you have understood you don't the point of tendency, then tangent PQ will be perpendicular to the radius KD according to rule 1. If PQ is perpendicular to KD, it means that this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to rule 1. So in this triangle KDO, this is triangle KDO, the right triangle KDO, we'll define this angle KDL. This angle KDL, we'll define this angle KDL as alpha. So in this right triangle KDL, this angle equals to alpha, this angle equals to 90 degrees, and therefore this angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, 90 degrees plus 90 degrees, it is equal to 180 degrees, it is the sum of the angles in any triangle. So we have the right triangle DBO and the right triangle DBO. This angle equals to alpha, this angle equals to 90 degrees, and therefore this angle must be equal to 90 degrees minus alpha according to the sum rule that says that the sum of the angles in any triangle is equal to 180 degrees. Therefore this angle must be equal to 90 degrees minus alpha. So in the next step, so this is the right triangle K, triangle OBD. So in the next step, we will do a construction, that is to say, from point P, we will do a perpendicular on BD. Again, from point P, we will do a perpendicular on BD. So actually, this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to our construction. We define the touching point of the perpendicular from point P and BD. This point is point T. So in this, by doing this construction, we created another right angle, triangle PTQ. This is the right angle PTQ. This right angle PTQ. This is the right angle according to our construction. This angle equals to 90 degrees minus alpha according to what we have already found out. Therefore, this first angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees. And 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in a triangle. Therefore, this angle must be equal to alpha. The next step, we prove that the green triangle OBD, this is the green right triangle OBD, can go into this right triangle QPT according to angle side angle rule. Again, we prove that the green triangle OBD can go into this right triangle OPT according to angle side angle rule. So in the norm, we have to prove that this is the green triangle OBD. You have to prove that the green OBD can go into this right triangle QTP. And again, we have to prove that the green right triangle OBD can go to the right triangle QTP. So while the green triangle OBD can go into this right triangle QTP. First of all, those two angles are both equal to alpha, and therefore they are equal to each other. So actually, this is the angle ODB in the green triangle, and is equal to this angle QPT in the white triangle. QPT. And again, we have found out that angle ODB in the green triangle OBD equals to angle QTP in triangle QTP. They are both equal to alpha, and therefore they are equal to each other. And we know that BD equals to 36 plus 11. 36 plus 11 is 45. That is to say, one side of this square, ABCD, is equal to 45 units in its length. So in the next step, we'll focus on this quadrilateral PTDC. This quadrilateral PTDC. This is a right angle because it is a square. ABCD is a square, therefore this is a right angle. Likewise, because of the fact that square ABCD, this is square ABCD, so this is also a right angle. All the sides of the angles inside the square are right angles. And this is a right angle according to our construction. So inside quadrilateral PTDC, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this third missing angle, so the mass equal to 360 degrees. According to the rule, that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 9 degrees in its size. So inside quadrilateral PTDC, we have 4 right angles, and therefore we can write to quadrilateral PTDC is a rectangle. Well, because it has 4 right angles. But you also know that the opposite sides of a rectangle are equal to each other. So in this rectangle PTDC, side CD is equal to 45 degrees, to 45 units. All the sides of the square are equal to each other, so each side must be equal to 45. So rectangle PCDT, side CD must be equal to the opposite side PT. But CD is 45, therefore the opposite side CT must be also equal to 45 units in its length. So we continue to prove that the green triangle OBD can go into this triangle QPT. We know that BD is 45. BD equals to 45. And it is equal to PT, it is also 45. If we want that BD equals to PT equals to 45. And finally, those two angles, they are both equal to 9 degrees and therefore they are equal to each other. Repeat again, those two angles are both equal to 9 degrees and therefore they are equal to each other. So actually this is angle B, this is angle QTP. In triangle QTP, and it is equal to this angle, this is angle OBD, the green triangle OBD. And again, if you want to know that angle OBD in the green triangle equals to angle QTP in triangle QTP, they are both equal to 9 degrees and therefore they are equal to each other. So in total, if you want to know that the green triangle OBD can went, this is the sum of can went to triangle QTP according to angle side angle rule. But again, if you found out that this is the green triangle OBD, the green triangle OBD can went to this triangle QTP according to angle side angle rule. That is to say, if you found out that those two angles and the side that is included between those two angles, that is side PT, this triangle PQT, are corresponding equal to those two angles, and the side that is included between those two angles in the green triangle BDC. OBD. Therefore, those two right angles can join to each other according to angle side angle rule. Again, we have those two angles, and the side that is included between those two angles, that is side BD in the great triangle, corresponding equal to those two angles. The side that is included between those two angles, this is triangle QPT. Therefore, those two right angles can join to each other according to angle side angle rule. And from the fact that those two right angles can join to each other, we will derive that their corresponding angles must be equal to each other in their lengths. Those are two right angles. The hypotenuse OD of the great triangle is the corresponding angle of the hypotenuse PQ of this right triangle PQT. That is to say, the hypotenuse of the great triangle is the corresponding side of the hypotenuse of this PQ, of this right triangle PQT. Or OD, the hypotenuse OD of the great triangle must be equal to the hypotenuse QP of this right triangle PQT. According to those, the corresponding sides of the congruent triangles are equal to each other. Those two triangles can join to each other, therefore the corresponding sides, that is to say QP and OD, must be also equal to each other in their lengths. So OD equals to QP. OD equals to QP. But we already found out that OD equals to 53. According to rule 10, OD equals to 53. So we can write here that OD equals to 53. And from this equation, 53 equals to OD equals to QP. We will derive that QP must be also equal to 53 units in its length. QP equals to 53 units in its length. That is the answer to the question. Again, tangent QP equals to 53 units in its length. And we already found out that the area of this square ABCD is equal to 2025 square units in size. So we finish to answer on the second question. In the next step, I'll solve the lecture. That is to say, I'll repeat on the solution of the first question and then repeat on the solution of this second question. In the first question, our task was to find out the height, the length of the height AB in this triangle ABC. So in the drawing, we have the triangle ABC, we have a circle that is described by this triangle ABC. BC equals to, the base BC equals to 40 units in its length. The radius of this circle is equals to 4 units in its length. Again, our task was to find out the length of side AB that is defined as the height of this triangle ABC. And to find out the length of AB. So first of all, we define the relevant points to this question with letters. We define the center of this circle, this point O. We define the point of tendency of tangent AC with this circle, this point F. Likewise, we define the point of tendency of tangent AB with this circle, this point E. And finally, we define the point of tendency of tangent BC with this circle, this point M. We join points O and M together by side line. Point O is the center of this circle, point M is the point of the circle itself, therefore OM is the radius of this circle, that is equal to 4 according to what is given in the question. The radius of M is equal to 4, the radius of M is drawn to point M, that is the point of tendency of tangent BC with this circle. Whenever you have this is drawn to the point of tendency, then tangent BC will be perpendicular to the radius of MO. If BC is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and D together by side line. O is the radius of this angle, equals to 4. The radius OA is equals to 4. The radius OA is on to point 8. That is the point of tendency AB with this angle. Whenever radius is on to the point of tendency, then tangent AB will be perpendicular to the radius EO. If AB is perpendicular to EO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. So in total, inside this small quadrilateral OEBM, we have 1, 2, 3 antennas. The sum of 3 antennas is 270 degrees, so 270 degrees plus the size of this 4-piece angle, the total must be equal to 360 degrees, according to the rule that says that the sum of degrees in any quadrilateral is equal to 360 degrees. And therefore, this 4-piece angle must be equal to 90 degrees in its size. So inside quadrilateral OEOMB, we have 4 antennas, therefore can relate to this quadrilateral EOMB as a rectangle. But we also know that the opposite sides of rectangle are equal to each other. So in rectangle EOMB, side EO must be equal to the opposite side BM. But EO is 4, therefore the opposite side BM must be also equal to 4 units in a second. Right? Why is according to the same rule? In the same rectangle OMBE, side OM must be equal to the opposite side DB. But OM is 4, therefore the opposite side DB must be also equal to 4 units in a second. So in total, we should find out that quadrilateral EOMB is not a rectangle but a square. Why? Because of the fact that all of its sides are equal to each other. Each side equals to 4. So here we can implement rule 2, but before that, what is the length of the missing side MC? For the moment, it is very easy to see that MC in total equals to BC minus BM. MC equals to BC minus BM. So MC equals to BC, that is 40, minus BM, that is 4. So in total, MC equals to 40 minus 4, that is 36. MC equals to 36 units in the same. Here we can implement rule 2. If you focus at this common sum point C, from this common sum point C, we have 2 tangents to this angle, tangent CM and tangent CF. And according to rule 2, they are equal to each other. That is to say, CM equals to CF. But CM is 36, therefore CF must be also equal to 36 units in this line. Likewise, we focus on this common sum and this common sum point A. From this common sum point A, we have 2 tangents to this angle, tangent AE and tangent AF. And according to rule 2, they are equal to each other. That is to say, AE equals to AF. So if we define the length of AE as x, then F must be also equal to x. And finally, we implemented the Pythagoras theorem on this big rectangle triangle ABC. According to the Pythagoras theorem, in a rectangle, the square of the hypotenuse equals to the sum of the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this big rectangle ABC, it means that AC squared is the square of the hypotenuse must be equal to AB squared plus BC squared. Repeat again, this big rectangle ABC, according to the Pythagoras theorem, you get that AC squared equals to AB squared plus BC squared. AC in total equals to x plus 36, therefore AC squared is x plus 36 squared. And it's equals to BA squared. BA is x plus 4, therefore BA squared equals to x plus 4 squared plus BC squared. BC is 40, therefore BC squared is 40 squared, it is 1600. So in total we found out that x plus 36 square equals to x plus 4 square plus 1600. So here we open the brackets on both sides of this equation and finally found out that x plus 36 square equals to x square plus 36x, that is 1296, plus 2 times x times 36, that is 72x. And it equals to, on the other side of the equation, we have x plus 4 square. X plus 4 square equals to x square, plus 4 square, that is 16, plus 2 times x times 4, that is 8x, plus 1600. We have x square on both sides of the equation, so x square gets cancelled. In this side of the equation, we have 1600 plus 16 is 1616. And we have 8 square. And it's equals to 1296 plus 72x. So in total, 1296 plus 72x equals to 1616 plus 8 square. Here subtracted x square from this equation, so here x square will get cancelled. And we're left only with 1616. When on the other side of the equation, we have 72x minus 8x equals to 64x. So in total, on this side of the equation, we have 1296 plus 64x equals to 1616. Here we subtracted 1296 from this equation. So in this side of the equation we left only with 64, while we have here 1616 minus 1600, well, 1616 minus 1296 equals to 320. So in total, I should found out that 64x equals to 320. Here we divide this equation by 64, and we found out that x equals to 320 over 64, that is 5. So x equals to 5 units in itself. Now let's find out the length of AB. AB is x plus 4, so AB is x, that is 5 plus 4, that is 9. 5 plus 4 is 9. So today we found out that AB equals to x plus 4, x is 5, so AB equals to 5 plus 4, that is 9. So AB equals to 9 units in itself. The answer to the question is that AB equals to 9 units in itself. So you need to repeat on the first solution. The next step, repeat on the solution of the second question. In the second question, our task is to find out the area of this square ABCD, and also we have to find out the length of this tangent QP. So in the drawing we have a semicircle and a quarter circle inside this square ABCD. This is tangent PQ that is tangent to both the semicircle and the quarter circle at this point. Again, first of all, we have to find out the area of this square ABCD. So, in the first step, we define the relevant points to this question with letters. We define this point as point K. We define KB as X. Likewise, we define this point as point L. We define BL as Y. Again, KB equals to X, BL equals to Y. And DL is the radius of the quarter circle, that is equals to 36 units in itself, according to what is given in the question. Likewise, AO is the radius of this semicircle, that is equals to 17, also according to what is given in the question. Likewise, OK is also the radius of the semicircle, that is equals to 17. This is square ABCD, therefore this is a right angle, this is a right angle, this is also a right angle. So first of all, the first question is to find out the area of this square ABCD. You know that the area of any square equals to the length of one side squared. Again, the area of any square equals to the length of one side squared. Therefore, the area of this square ABCD must be equal to the length of one side, that is AB squared. The area of square ABCD must be equal to the length of one side of square ABCD squared. We choose the length, the side of AB, so it is AB squared. The area of square ABCD equals to AB squared. AB in total equals to 17 plus 17, this is 34 plus x. AB is 34 plus x, therefore AB squared equals to 34 plus x squared. AB squared equals to 34 plus x squared. So according to the first method of calculation, we have found out that the area of square ABCD equals to 34 plus x squared. The next step, we calculated the area of this square ABCD in a different way. We choose side BD as one side of this square, so the area of this square ABCD must be equal to BD squared. According to the second method of calculation, the area of the same square ABCD must be equal to BD squared. BD in total is 36 plus y, therefore BD squared is 36 plus y squared. So in total, we found out that the area of square ABCD, according to the second method of calculation, equals to 36 plus y squared. So we have two different equations for the area of the same square ABCD. This is equation 1 and this is equation 2. Therefore, get on the question 3 that says that the area of square ABCD according to the first method of calculation must be equal to the area of the same square ABCD according to the second method of calculation. The area of square ABCD according to the first method of calculation equals to 34 plus x squared. It must be equal to the area of the same square ABCD according to the second method of calculation is equal to 36 plus y squared. So in total, according to equation 3, we should find out that 34 plus x squared equals to 36 plus y squared. If we took out from this equation 3, we found out that 34 plus x equals to 36 plus y. Why? Because of the fact that the square cancels the root, and we left only with 34 plus x, and that's the equation, we left with 36 plus y. If subtracted 34 from this equation 3, that here 34 we can cancel, and that's in this side of the equation only with x value. On the other side of the equation we have 36 plus minus 34 is 2. So this side of the equation we left only with y plus 2. So in total, according to equation 3, we actually found out that x equals to y plus 2. So in the next step, implemented Pythagoras theorem on this great triangle, triangle OBD. According to the Pythagoras theorem, in any right triangle, the square of the opposite equals to the sum of the sides of the perpendiculars. But before that, we found out the length of OD, the length of the opposite OD. We found out the length of OD by implementing rule 10 in our drawing. In the drawing, we have those two, the semicircle and the quarter circle, touch each other externally at point K. Therefore, we can implement here rule 10 and click on rule 10. According to rule 10, if two circles touch each other externally, then the straight line that connects the circles together passes through their touching points. In the drawing, we have those two circles that touch each other externally at this point, point P. The center of this circle is at point O. The center of this circle is at point M. The straight line that connects the circles together is, of course, the straight line OM. According to this rule 10, the straight line OM must pass for point P, that is the starting point. Or OPM is one straight line. OPM is one straight line, therefore, if OPM is one straight line, it means that OM must be equal to OP plus PM. So we can actually implement rule 10 in our drawing. Because in our drawing, the semicircle touches the quarter circle at this point, point K. The center of this semicircle is at point O. The center of this quarter circle is at point D. The straight line that connects the circles together is, of course, the straight line OD. According to rule 10, the straight line OD must pass through their touching point, that is point K. Again, the straight line OD must pass through point K, that is the touching point. Or OKD is one straight line. Again, OKD is one straight line according to rule 10. If OKD is one straight line, it means that OD in total must be equal to OK plus KD. OK is the radius of this semicircle, that is 17, plus KD. KD is the radius of this quarter circle, that is 36. So in total, OD equals to 17 plus 36, that is 53. OD equals to 53 units in itself. So the hypotenuse of this great triangle OBD is 53 units in itself. So in the next step, we implement the Pythagoras theorem on this great right triangle OBD. So according to the Pythagoras theorem, in this right triangle OBD, OD squared, that is the square of the hypotenuse, equals to OB squared plus BD squared. And again, in this great triangle OBD, according to the Pythagoras theorem, OD squared, that is the square of the hypotenuse, equals to DB squared plus OB squared. OD is 53, therefore OD squared is 53 squared, that is 2,809 plus OB squared. OB is 17 plus x, therefore OB squared is 17 plus x squared plus BD squared. BD is 36 plus y, therefore BD squared is 36 plus y squared. So in total, we found out that 2,809 equals to 17 plus x squared plus y plus 36 squared. Again, 2,809 equals to y plus 36x plus 17 plus x squared. But we have already found out that x equals to y plus 2. We found out that x equals to y plus 2. therefore we can substitute x in this equation by y plus 2. We did it, and we found out that 2809 equals to 36 plus y squared. Here we have 17 plus x. X is y plus 2, so therefore 17 plus x is 17 plus 2 plus y. This is to say it is 19 plus y squared. So in total we found out that 2809 equals to y plus 36 squared plus 19 plus 2 squared. So 2809 equals to y plus 36x. Y plus 36x equals to y squared plus 36x, that is 1296, plus 2 times y plus 36, that is 72y, plus 19 plus y squared. 19 plus y squared equals to 19 squared, that is actually 361, plus y squared, plus 2 times y times 19, that is 38y. So in this side of the equation we have 2809, y squared plus y squared is 2y squared. Here we have 72y plus 38y is 110y. And we have also here 1296 plus 361 equals to 1657. So total, if you found out that 2809 equals to 2y squared plus 110y plus 1657. So here we subtracted 2809 from this equation. So here 2809 cancelled, get cancelled, and we have only 0. We have 0, while on the other side of the equation we left with 2y squared plus 110y, and 657 minus 2809 equals to minus 1152. So total we found out that 0 equals to minus 1152 plus 2y squared plus 110y. Here we divide this equation by 2, and so we found out that 2y squared over y is y squared, 110y over 2 is 55y, and minus 1152 over 2 is minus 576. 0 over 2 is 0. So if you found out that y squared plus 55y minus 576 equals to 0. So actually this is a quadratic equation, and the general formula for a quadratic equation is as follows: ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we found out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say y squared plus 55y minus 576 equals to 0, the variable that we are looking for is y, so x equals to y. The coefficient a equals to 1, the coefficient b equals to minus 255, and finally the coefficient c equals to minus 576. So we have all the data that is needed in order to find out the variable that we are looking for this question, that is y. So we just have to put the data, this data in this general formula for x, and this way we find out the value of the values of y, because y might have two solutions. So we did it, and we found out that x equals to y, so we substitute x by y, and it equals to minus b. B is 55, therefore minus b is minus 55, plus minus square root of b squared. B is 55, therefore b squared is 55 squared, that is 4,525, minus 2 times a times c, so it is minus 4 times a is 1, so minus 4 times 1 is minus 4 times c. Minus 4 times minus 576 equals to 2,304, divided by 2a. A is also 2a, 2a is 2 times 1, that is 2. So in total we found out that y equals to minus 55 plus minus 3,025 plus 2,304 equals to 5,329 divided by 2. So in total we found out that y equals to minus 55 plus minus, let's go to 5,329 is 73. So in total we found out that y equals to minus 55 plus minus 73 over 2. You choose only the positive solution to this question, because y is a left, and the left must be a positive number. So we choose the solution that says that y equals to minus 55 plus 73 over 2. Minus 55 plus 73 is 19, and 19 over 2 is 9. Oh, so y equals to 9 units in its length. So in total we found out that y equals to 9 units in its length. Found out that y equals to 9 units in its length. We only found out that y equals to, that x equals to y plus 2. So x equals to y, that is 9 plus 2. 9 plus 2 is 11. So x equals to 11 and y equals to 9. And our task in the first part of this question, we have to find out the area of this square ABCD. The area of square ABCD equals to the length of one side squared. We choose side AB, so it is side AB squared. The area of square ABCD equals to the length of one side, that is AB squared. AB in total is 34 plus x, therefore AB squared is 34 plus x squared. AB squared equals to 34 plus x squared. X is 11, so 34 plus x is 34 plus 11 squared. 34 plus 11 is 45, so it is 45 squared. 45 squared is 2025. So in total we found out that the area of this square ABCD is equal to 2025 square units in its size. The next step, we found out the length of this tangent PQ. So what is the length of PQ? So first of all, we did the construction, that is to say from point P, we draw perpendicular on BD. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and BD. This point is point T. By doing this construction, we get the right triangle QTP. This right triangle QTP. But before that, so we created the right triangle QTP, but before that, in this right triangle OBD, we define this angle BDO as alpha. So in this right triangle OBD, this angle equals to alpha, this angle equals to 90 degrees, and therefore this missing angle must be equal to 90 degrees minus alpha. 1 plus 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, in this right triangle QTP, we have but before that we have in this triangle we have here rule 1, tangent QP is tangent to this semicircle, tangent QP is tangent to this quarter circle at point K. So the radius OK is equal to 36 is drawn to point K, that is the point of tendency of tangent QP with this circle. Whenever your radius that is drawn to the point of tendency, then tangent PQ will be perpendicular to the radius KD. If PQ can perpendicular to KD, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. So in this Green's form triangle QKD, this angle equals to alpha, this angle equals to 90 degrees, and therefore this missing angle must be equal to 90 degrees minus alpha. And we already found out that according to rule 10, in total the opponent OD of this rectangle OBD equals to 17 plus 36, that is 53. Also OD equals to 53. So here we have the green triangle OBD can go into this right triangle QPT according to angle side angle rule. So why the green triangle OBD can go into this right triangle QPT? First of all, those two angles are both equal to alpha and therefore they are equal to each other. Here PT equals to 45. This triangle QPT is equals to BD. One side of this square is 45, so BD also 45. So those two sides are equal to each other. And finally, those two angles, they are both right angles and therefore they are equal to each other. So in total, we found out that the green triangle OBD can go into this triangle QTP according to angle side angle rule. The green triangle OBD congruent, this is the same congruent to triangle, to right triangle QTP according to angle side angle rule. Okay. Those two triangles congruent to each other according to angle side angle rule. But before that, after we did the construction, so this angle equals to 90 degrees according to our construction, because we don't perpendicular from point P to BD. So this angle equals to 90 degrees according to our construction. Those two angles are both right angles because ABCD is a square. So in quadrilateral PTDC we have three right angles, 1, 2, 3. Therefore this first angle must be equal to 90 degrees in size. Therefore quadrilateral PTDC is a left angle. But we also know that the body sides of a rectangle are equal to each other. So in rectangle PTDC, side CD must be equal to the opposite side PT. But CD is 45, therefore PT must be also equal to 45 units in itself. So repeat again, the great triangle OBD congruent to this right triangle QPT according to angle side angle rule. Those two angles are both equal to alpha, therefore they are equal to each other. PT equals to BD equals to 45, and therefore, also those two angles are both equal to 90 degrees, and therefore they are equal to each other. In total, we found out that the great triangle OBD congruent to the right triangle PQT according to angle side angle rule. That is to say, we found out that those two angles and the side that is included between those two angles, that is side PT, this triangle PQT, was equal to those two angles, and the side that is included between those two angles, that is side BD, in this triangle OBD. Therefore, those two angles can point to each other according to angle side angle rule. We have those two angles and side that is included between those two angles in this triangle, was equal to those two angles, and the side that is included between those two angles in this triangle QPT. And therefore, those two angles can point to each other according to angle side angle rule. And from the fact that those two angles can point to each other, that is to say, from the fact that the great triangle OBD can point to this right triangle QPT, we will derive that their corresponding sides must be also equal to each other and their lengths. OD is the hypotenuse of the great triangle OBD, and QP is the hypotenuse of this triangle OTP. So the hypotenuse OD is the corresponding side of the hypotenuse QP. Therefore, OD equals to QP. According to the rule, the corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore their corresponding sides must be equal to each other in their lengths. That is to say, PQ equals to OD. PQ equals to OD, but we already found out that OD equals to 53, so we can write that OD equals to 53, and from this equation 53 equals to OD equals to QP, we will have that QP must be also equal to 53 units in itself. This is same as QP equals to 53 units in itself, and when we found out that the area of this square ABCD equal to 2025 squares inside. Okay, thank you very much.